Oh, geez, sorry, I didn't see that the camera was on. Yeah, sorry, I was just practicing my banjo. Guess I'll have to start some Tibbetts physics. So why don't we get started? Today, we're going to continue our lesson on precision and accuracy, except now we're going to look at significant figures. Let's see, significant figures. Okay, so they're most commonly known as Sig Figs, for short. Or Fig Newtons. We'll actually look at Fig Newtons when we talk about Isaac Newton in a few more units. So Sig Figs is a degree of precision of your measurements. And we're going to do two things today. We are going to look at the number of Sig Figs, so we're going to be able to count them, as well as how do we use Sig Figs when we're adding, subtracting, multiplying, and dividing numbers. So let's start off with counting Sig Figs first. And we have two methods of doing this. It depends on whether or not the decimal is present or if the decimal is absent. So let's look at when the decimal is present first. So what we do is we count we count left to right, sorry. Left, not left. Count left to right, starting with the first non-zero number. With first non-zero number. So that's anything but 0. We'll do some sample problems together. Let's look at when the decimal is absent. Decimal absent. This time we count in the opposite direction, so from right to left. And this is also starting with the first non-zero number. Starting with first non-zero number. So a quick way to remember this is, if you know in Asia they read from right to left. So when we count, if the decimal is absent, A for Asia, right to left. In P, well, I guess we could say every other person counts from left to right. So if P is present, we count from left to right. Okay, so let's do some example problems. Counting Sig Figs. So let's look at the first one. 568. The question is, well, there's no decimal, so we count from right to left, and we count the first non-zero number. So starting at the 8. 1, 2, 3. So there are 3 Sig Figs. Pretty simple. Let's look at 560. Right to left, no decimal, so we start at the 0, but the 0 is a 0, so we have to look at the first non-zero number. So we don't count that one. 6 and 5. Again, counting right to left. So this time there are 2 Sig Figs. Let's look at 560.0. This time, decimal is present. So we have to do the opposite. We're counting from left to right, the first non-zero number. So left to right, first non-zero number is 5. So 1, 2, 3, 4. We count everything after it. 4 Sig Figs. Let's look at another one with a decimal. Let's look at 0.00005428. So again, left to right, sorry. first non-zero number. So that's a 0, that's a 0, 0, 0, 0. That 4 is our first non-zero. So 1, 2, 3. 3 sig figs. What if we have something similar to that? We have 0.0000428. We follow the same method. Left to right, first non-zero number. Start at the 4 again. 1, 2, 3, 4. That last 0 counts. So now we have 4 sig figs. Why don't you try this one on your own, or try these 3 actually. We've got 3,000, so let's be an example. 3,000, 3,000 with a decimal point after it, and 3 times 10 to the 3. So try those on your own. For the first one, decimal is absent, so we're counting right to left. First non-zero number, zeros don't count, so we start at the 3, 1 sig fig. Second one, we have a decimal, so we're counting left to right. Start with the first non-zero number, that's our 3. So 1, 2, 3, 4. 4 sig figs. Last one's a little bit tricky. We're going to say since there's no decimal, we're assuming that the answer is 3,000. So in this case, it has just 1 sig fig. Okay, so the last thing we're going to do is learn how to add and subtract sig figs, as well as multiply and divide. We'll do adding and subtracting first. So the rule is you round your answer off to the least amount of decimals, to the number with the least amount of decimals. So I'll just do one quick example. I think it's pretty self-explanatory once you can do one. So the first one, we have 32.6 plus 431.33 plus 6144. Those are 4s, not 9s. 0.212. We're going to add these suckers up. So we do this really quick in our head, and we get 6608.142. Now when we round this, we have to look at the number with the least amount of decimal places. That's this one. So our answer is going to be rounded to the least amount of decimal places, which in this case is tenths. So here's the tenth spot. We ignore the rest. We're not rounding up because it's not 5 or above. So our answer is 6608.1. All right, let's look at multiplying and dividing sig figs. Multiplying, dividing, not dividing, sig figs. This time our answer is rounded to the number with the least amount of sig figs. Okay, so let's do a quick example for this one. So we got 1.36 times 4.2. Okay, quickly in our heads we get 5.712 for our answer. And let's look at which number is the least significant. So decimal is present in both of them. We're counting right to left. This one has 3 sig figs. This one has 2 sig figs. So our answer could only have 2. Decimal is present over here, so we're counting right to left as well. 5 is our first one, 7 is our second one. So our answer, only 2 sig figs, is 5.7. And that is it for today. Thank you for watching Tibbetts Physics. We will see you next time. Have a great night.